Hey, welcome to Protec Live. This is Matt Medinka, Director of Marketing for Protec. I'm here with the Tom Sandry, Director of Technical Services for Protec. Many of you know him. He's been in the industry for over 30 years now, and he's my smarter half. Tom, we've had so many people say, hey, when are you going live again? They saw us do this marathon live broadcast at Power Test. And so we said, yeah, we need to go live again. It's been a while since we've done that. And so we have a great topic today, and I'll let you introduce the topic.
Okay. Thank you, Matt. Today we're going to just kind of take a little bit of time to talk about electrical safety, talk a little bit about legislation. And when I refer to legislation, typically in that context, I'm referring to like OSHA here in the States, or I believe it's OHS of Canada for any of our Canadian viewers and everything. So when I use that term legislation, that's kind of what I'm referring to. But in the process of talking about electrical safety, legislative requirements, we're also going to touch base on what I'll refer to more as an industry or national standards, which would be like the NFPA 70E or the Canadian CSA group Z462, which basically dictates electrical safety in the workplace. So those are going to be our main topics that we're going to be covering throughout this live broadcast.
And before we get started, I just want to welcome everybody who's watching from YouTube, everybody who's watching from Facebook, everybody who's watching from LinkedIn. We're actually streaming live from all three platforms at one time. Welcome. If you are on Facebook or YouTube, you should be able to put a question or put a comment right in the chat window there. We're monitoring that, so feel free to do it. And this is going to be a lot more interactive than our webinars. So if you want to make a comment or ask a question, please feel free to do so. If you're joining us on LinkedIn, a little bit harder to do that on LinkedIn, but if you want to put a comment in the comment section of our post, you're welcome to do that. We'll pay attention to that as well. And if something comes up, we'll certainly, Tom, I'll interrupt you and we'll talk about that. So let's get going. So I guess first you're going to introduce what is the NFPA 70E and the CSA Z or Z462 standard?
Come on, Matt, you got to get
depends if you're Canadian or not, right?
Here it's Z. Yeah. Get with that Canadian lingo. Well, first and foremost, here in the States, we kind of refer to it as a national standard. But the key thing I want to make known about the whether it's the NFPA 70E or it's the Z462 version that is utilized in Canada, these are considered voluntary standards. Now, your legislation, which dictates and defines safety, qualifications, trainings, et cetera, procedures, policies, practices, et cetera, your legislation obviously is the mandatory and the enforceable. Okay. The 70E and the Z462 serve more as voluntary or reference-based standards that are out there in order to provide guidance in meeting legislation. Now, I do though want to make a point though that if you choose to use them, you will then be held accountable against them. Okay, so although they are voluntary, if you do choose to use them, you will at that point then be held accountable against what's written in those standards.
So that's interesting. So let's dive into that a bit. So obviously there's an employer responsibility once you commit to doing that, and there are certain requirements they have to follow and be held accountable for. So let's go through those.
Very good. Well, definitely when we start talking about employer responsibility and employer requirements, probably kind of right up there at the top is the establishment and development of what is known as an electrical safety program. And basically, it's a documented system consisting of electrical safety principles, policies, procedures, and processes that directs activities appropriate for the risk associated with the electrical hazard. Now, an electrical safety program is kind of an all-encompassing term for an employer's documented system of evaluating hazards, providing the appropriate actions necessary to protect employees from injuries, electrical injuries in this case. And here we kind of see guidance like in the NFPA 70E, Article 110.5 provides the required elements of an electrical safety program. So they'll provide guidance and tell you these are the elements that need to be in the electrical safety program that you develop for your organization. And then in Annex E of the 70E, they provide descriptions of, well, give me examples of like safety principles, controls, and procedures. So here we definitely see where like the 70E or the 462 would now start to provide guidance of how to go ahead and build and put together your electrical safety program. Now, in the standards, again, the 70E or the 462, in the 70E, it's actually covered in Article 110, general requirements for electrical safety related work practices. And right at the very beginning of that section, 110.5, it talks about electrical safety program. And in paragraph A, general overview, it basically states that the employer shall implement and document an overall electrical safety program that directs activity appropriate to the risk associated with electrical hazards. So again, one organization's electrical safety program might be slightly different than another organization's electrical safety program based upon the type of work and the type of exposure that those employees at those various organizations would face. Okay. Now, again, when it comes down to I've built my electrical safety program, other responsibilities that fall into play here. You need to keep in mind that standards change. They go through revisions as we learn more or we try to make it more understandable or we want to draw a better emphasis to certain areas that we maybe in a past revision we felt we didn't do a justified job of emphasizing. Bottom line is we need to keep in mind that these standards are dynamic. They change. They go through revisions as we, as a society, become smarter and more educated and so forth. Now, the 70E and the Z462 undergo revisions every 3 years. Now, in 2021 was the release of what is now the latest edition or latest revision. Prior to 2021, obviously, subtract 3, it was the 2018 revision. Okay. Now, how this affects you and your electrical safety program? Well, in the document, it basically defines that you need to audit your electrical safety program in time intervals not to exceed every 3 years. In essence, you need to review your electrical safety program. You need to do a gap analysis. Has things changed in the latest editions of the safety standards? Am I meeting them? Is there a gap? And then create an action plan in order to bring your electrical safety program up to the current revision levels. So as we can see, the required audit cycle of your electrical safety program basically aligns with the revision cycle of the industry standards.
So there's an initial training then once you commit to doing this, right? And a lot of companies are already doing this, right? They're following the 70E standard. There's that initial training of the employee who's never been trained before. And then I'm assuming there's like, they got to retrain if there's an addition to the standard. And then they have to keep those records. So there's additional training, there's retraining. There's that constant flow of new people coming within the organization. Let's talk about that for a bit.
That was a really good lead, and I like the way you described, because when we really look at training and education, it's a never-ending, and I like to think of it more as a process. There's really no end to it because the world is forever evolving, and we're students of life. We're constantly learning. New equipment is being designed regularly. I mean, if we compare some of the new modern designs in like switchgear that are coming out today versus, what was available back in the 60s and 70s, I mean, tremendous changes. Obviously, we need to be trained and educated on how to get the best effectiveness and everything out of these new designs. So again, we are students of life. Training is a never-ending process. But kind of back on focus here a little bit. Employers need to evaluate the workplace for known hazards. Now, for our discussions, obviously, we're focusing in on electrical hazards. Now, that's wonderful if you work at like a petrochemical plant. Your employer at that plant will evaluate all the known hazards and everything there. Now, maybe a little bit more pertinent toward like a service provider, a company that goes out there and does maintenance or service work. Here, if there are inherent hazards associated with the type of work being performed, then the employer has the responsibility to provide the safety and awareness training to keep the worker safe based on the worker's level of training and their competency. Okay, so definitely that second statement, would apply to like a test company and everything, because you can evaluate the safety at your facility, but your workers are rarely at your facility. They're going and visiting other locations. Now, that host employer needs to inform them and train them of any safety-related issues of working at their facility. But you, as the employer of that service worker, there would be inherent dangers that or hazards that they may face in the line of their work that they perform for the clients. So you would be responsible for training them and bringing awareness and everything of those hazards that they would be facing.
So who's typically, like, from a company perspective, who's monitoring that? Like, what person, do they have somebody specifically employed for that? Or is it somebody who's in another role that kind of oversees that as part of their job description?
I'd say the areas where you would normally find this responsibility landing, but keep in mind, you may have a designated department or set of individuals that kind of oversee, but when it comes to safety, it really is a culture of the organization. And I mean, in all reality, every individual in that organization is responsible, from the worker to the supervisors to the managers to everybody in that organization ultimately is responsible. It really is a culture. But if you want to position it into like a departmental area of who would kind of orchestrate or have top level oversight, a lot of times you'll find it in the occupational health and safety department, or sometimes referred to as the environmental health and safety, or EHS, or sometimes you'll see it in the what they refer to as like the workforce development group. Right. They would normally kind of oversight, but the point I really want to make is it really is a culture, and everybody has a responsibility.
So it's important for everybody to keep up with the changes then. And we'll get into the actual changes to the standard in a minute, but right, it's the duty of everybody.
Exactly. Now, as far as the requirement of training and education and everything, this has long been a legislative requirement. And in general, most companies are very familiar with possible shock hazards, and they are aware that legislation requires that their qualified workers be properly trained to work on or near energized components or circuits. Many organizations, however, are unaware that the legislation also applies to the training of unqualified electrical personnel on how to recognize and avoid electrical hazards. And when we talk about unqualified electrical personnel, we might be referring to like maintenance people, painters, cleanup crews, laborers, machinists, etc. These individuals are not necessarily expected to work on live energized equipment, but they still need to be trained and to receive sufficient training to ensure their safety and the safety of others in the workplace. One of the areas, whenever we teach, qualified electrical worker training and everything, one of the areas that we always get into is identifying normal operating condition. Now, in the NFPA 70E 2021, is referred to as normal operating condition. In the Canadian CSA Z462 2021 revision, they changed the terminology a little bit to make it a little bit more descriptive of what they're going after. And they call it normal equipment condition. Okay. But basically, what this states is that the worker must understand and be able to assess a normal operating or a normal equipment condition versus an abnormal condition. Obviously, an abnormal condition, risk goes up because things will not necessarily be expected to perform the way they were intended. Now, in the documents, they basically list like 6 levels or 6 areas that you really need to scrutinize to ensure that it is in a normal condition. 1, was it installed properly? 2, has it been maintained properly? 3, is it being used in accordance with the original equipment manufacturer's design parameters? 4, are the panels closed and doors, latches and everything secure? Are the panels and everything all in place and are they secured? And then finally, is there any evidence or signs of impending failure in the equipment? And all of these 6 must be met in order to say then, yes, that piece of equipment is in a normal condition. If any of those 6 are not met, it is then referred to as either impaired, deranged, or simply an abnormal condition, and risk goes up. That needs to go into your overall evaluation. Now, many organizations will feel that they can conduct an assessment on behalf of the worker of whether it is a normal or abnormal condition. But this would be a false statement. The organization really can't do this assessment on the behalf of the worker. The worker needs to have the skills and be able to go out to the equipment and assess the condition of the equipment before they perform any type of task on that equipment. The worker has to have that skill. Again, I can't just sit in my office, write a guide, because it's not real time. I mean, when the worker goes out to that equipment, something may have occurred or whatever. They have to be able to recognize and understand. So again, the worker needs to have that skill, knowledge, and capability and familiarity with the design and operation of the equipment that they intend to be working on. Now, that leads us into the term qualified worker. We throw this term out, so much. The task can only be performed by a qualified worker who is supplied with and uses appropriate safe work practices and PPE. And we just constantly use this term qualified. So, what is the definition of qualified as far as the 70E or the Z462 is concerned? Well, it's documented right in the guide. It basically states qualified means one who has demonstrated skills and knowledge related to the construction and operation of electrical equipment and installations and has received safety training to identify the hazards and reduce the associated risk. Now, there are a couple of very, very key words that are being used in that definition. Okay, has received safety training. So they have received a transfer of knowledge. That's very important. Okay, but possibly even more important, there is a measurement of the effectiveness of the training. In the statement, demonstrates skills, demonstrates knowledge. So I've transferred knowledge to you, but now can you use it? Can you apply it? Do you have the ability to demonstrate those skills and knowledge in the application? So as we see in this definition, simply training a worker does not deem them as qualified. Just because they took a 1-hour course, 1-day course, 2-day course, 3-day course, whatever, it does not necessarily deem them as qualified. There's much more to, and I like to think of it as a process, okay? There's much more to the process of becoming qualified. Again, as I mentioned, there must be a measurable outcome. Okay. Now, in training, we have obviously that knowledge transfer that takes place. And this transfer of knowledge, we can assess it by providing a test or exam at the end of the training. So when you've taken the course, we've transferred knowledge to you. At the end of the course, you take your exam, and we're assessing your ability to take in that information. Okay. What we haven't done, though, is we have not applied a measurable on the outcome. So the measurable on the outcome would come through, for instance, like a competency validation process where we now oversee, we maybe have you put together a risk assessment. Maybe we can give you a job scope and parameters and so forth. Measure your ability of utilizing everything that you've learned, formulating a risk assessment plan, applying that knowledge, selecting your PPE, etc. Now, in other cases, the measurable might be actually have you perform exercises on the job to actually demonstrate and show to your supervisor your proficiency and ability to perform that task. So these are all very key elements into becoming what is qualified. Okay.
So what you're saying basically is, I mean, a lot of people are doing QEW courses now. You can take the 30-minute, $49 online thing. You can do a live in-person one. You can do a hybrid, which is what we do, where you're online, but you're instructor led. But whatever you do on QEW, when you get that piece of paper, that doesn't mean that person is a qualified electrical worker. The company has to have a process in place to actually measure that with the person hands-on.
Correct.
Like I think we were talking about this the other day. Hey, can you actually, can you rack that Siemens breaker? Can you rack that? Right. You're talking about, okay, well, I have to see you do it. Right. So what's the process the company has in place to make sure that happens? There's a liability there for sure.
Absolutely. Because remember, when you've taken that class, whether it was the 30-minute or the multiple day class or whatever, that was a transfer of knowledge. Okay. And now some will come back and argue and say, well, I took a class and they took me into a lab setting and they had some simulated gear there and I got to rack a breaker. Therefore, I'm qualified on racking a breaker. I'm going to caution you here. Okay. That would be a little bit of an oversimplification of the interpretation. What you also have to remember is in the overall qualification process, I mean, let's face it, there are a plethora of gear out there in the field spanning decades of design generations, not to mention various vendors and manufacturers building the gear. There are various tasks that you might be asked to perform on this gear of varying vintages and varying manufacturer designs. So in the documents like the 70E and the 462, they also are very key in the informational notes to make a point of saying a person might be qualified to perform a specific task on specific equipment while being unqualified to perform another task on the same piece of equipment. Also, qualification does not necessarily carry over to a similar piece of equipment, nor to an identical task on a different piece of equipment. Work practices, procedures, and hazards can vary by the task and by the equipment that you're touching. Again, anybody that has worked in the field for any length of time, I think, can agree to this statement. A Magna Blast is a breaker, and then any of your other brands or more modern day breakers. They're all breakers. We basically understand what the purpose of a breaker is, interrupt flow of current, et cetera, et cetera. But there is a order of magnitude difference in the way these operate. And really what the legislation and what the standards are trying to get at here is it's not a one-fit-all model. you may be familiar with the task, but you've never touched or handled that particular piece of equipment before. Again, going back to that definition of qualified, you have to have knowledge of the equipment that you're working on. So if you've never worked on it before, you're not qualified until you get that training and that knowledge on that specific equipment or on that specific task. Okay. Now, also, qualification is not necessarily based on title, licensure, and so forth. Okay. For an example, you may be a highly credited licensed electrician, but not be qualified to work on medium voltage switchgear. So to be qualified, the person must have the knowledge and the demonstrated skills concerning the specific hazards, the work practices, and the procedural requirements of the gear and the tasks that they will be either working on or performing.
So we talked about that knowledge transfer. Then I guess kind of what I want to get into is first, what do these standards say about the training? Like, what are the requirements? And then let's get into, I know 2021 was the latest standard update. I think for both of these standards. Let's get into some of what those changes were.
Well, actually, before we get into the changes in the standard, one area I'd like to touch base on a little bit is the types of training that is out there. Because I will say the COVID and the pandemic has kind of opened up and changed the view of how training is delivered in the post global what's the term I'm looking for there, Matt?
Pandemic world.
Pandemic, thank you. Yeah.
Yeah.
So let's touch a little bit.
We're all Zoom proficient now. Yes.
So let's touch base a little bit on the types of training, because I think pre-COVID days, we might have been a little bit more stringent on hardcore in that physical classroom trainings and so forth, hands-on and so forth was the approved methodology. But the pandemic, has changed a lot of our viewpoints. And we're starting to see this reflective in the new 2021 revisions, where training can include interactive electronic or interactive web-based components. Now, these will potentially provide information, but not necessarily assess the learner's ability to receive that information or to implement that information. So as we discussed earlier, I can assess whether I'm using interactive electronic or interactive web-based components in my training. I can assess your ability to take in that information through a final exam at the end of the training. Also, I can incorporate interactive elements that engage the worker. This can also assess the learning process, assess the learner's ability to be taking in that information. But the key in this next stage of the process is the measuring of the outcome. Okay. I finished my training class on Wednesday. Thursday, I report to work. What is your measurable to say, am I applying what I learned and am I applying it properly? Am I doing what I was taught?
So you don't,
so
this guy doesn't want to just go back to work and pick up where you left off. Like the company has to step in now and say, okay, let's look at your proficiency.
Exactly. So here's where on-the-job training really becomes a very, very valuable tool for those organizations who have adopted on-the-job training. And again, on-the-job training is not send the worker out to work and unsupervised say, okay, you sat in class for 3 days, now just go and get it all done. That's not on-the-job training. That's on-the-job assignment of duty, okay? On-the-job training is where the worker is still under supervision of somebody who is proficient and has the competency and is qualified in those tasks or on that equipment. They're overseeing the worker, but on the job, now we can start to provide application-based and proficiency-based exercises. So under the guidance of a qualified worker, you now can demonstrate your proficiency and your ability to implement your knowledge on the tasks and on the equipment that you were trained on. So again, the key and sometimes overlooked element is that measured outcome. What is the measurable outcome of the training that you received? The final exam is not the measured outcome. That's just an assessment of how you took in the information.
Got it. Let's get into some of these revisions now. So the latest I know for NFPA 70E is 2021. The CSA's Z462 is also 2021. Is that a coincidence, or they typically are in alignment on their update years?
70E and Z462 have long been in alignment with one another. So when we look at the revision schedules, 2021, 2018, 2015, so on and so forth.
Every 3 years.
Every 3 years. So for the longest time, the CSA and the NFPA have been in this alignment with one another. Now, an interesting thing happened in 2021 editions. We now start to see a divergence taking place between the Canadian Z462 and the NFPA 70E. We see some subtle divergences where, as I mentioned earlier, if you're reading the 70E, they're going to refer to normal operating condition. If you're reading the CSA Z462, they're going to be referring to normal equipment condition. So there are some soft or subtle areas of deviation taking place or divergence taking place. But the one that I wanted to bring up in this live broadcast is in the area of Flash PPE categories. Now, in the 2018 revisions of the documents, when we got into Flash PPE categories, we had level 1, level 2, level 3, and level 4. Okay. Level 1 was to provide a minimum protection of up to 4 cal per centimeter squared. Level 2, up to or minimum of 8 cal. Level 3, minimum of 25 cal. And a level 4, minimum of 40 cal per square centimeter. Now, in 2021, if we look to the 70E, we still see 4 categories or 4 levels. But if we look at the CSA Z462, we now see a category 5 carrying a minimum arc rating of 75 cal per square centimeter or centimeter squared. So this is a rather big divergence between the two documents now. We have a whole new category level in the Canadian document. Okay, so what was the catalyst? What created this divergence? Well, it really goes to yet another document. The 70E and the Z462 in their Annex D, which describes the calculations required to perform like an arc flash assessment or study, how to actually calculate incident energy. This is drawn from the IEEE standard 1584, which is the guide for performing arc flash hazard calculations. Now, this is rather important, and let me kind of bring up this slide here referring to 1584 electrode orientations, because this is kind of an important area that we need to kind of home in and understand here a little bit more. Okay, so the IEEE 1584 launched a new edition in 2018. The previous edition goes back to 2002. Now, in the previous 2002 edition, the only orientations that were listed were what's called VCB, or vertical electrodes in a metal box or enclosure, and VOA, vertical electrodes in open air. So all the calculations and everything of determining, incident energy, or arc flash risk was based on only these two orientations of the electrodes or the cables or bus going into the gear. Okay. Now, in the 2018 edition, they now added VCBB, which is the vertical electrodes terminating in an insulating barrier in a metal box. They added the HCB, horizontal electrodes in a metal box, and the HOA, horizontal electrodes in open air. So with the review of 1584, the two committees, I'll just call it the 462 committee and the 70E committee, obviously they had to review the new 1584 and see, how it affected the standards. So the Canadian team went and they started crunching numbers, okay, actually working these calculations. And let me just go ahead and, there we go, bring this slide up now. Okay, so when the Canadian team started going in there and crunching the numbers, based on the new electrode orientation and the new calculations that they were seeing in the 1584, particularly when they were dealing with 600 volt class switchgear with maximum available fault currents of around 35,000 amps, maximum clearing times of up to 30 cycles, and working distances of 18 inches. When they ran through these calculations, they saw that, oh, wait, when we get into like the new VCBB and the new HCB orientations, our energy calculations are coming out well beyond 40 cal. I mean, as we see in the slide here, for the VCBB, their calculations were coming out to 51 cal, and for the HCB horizontal in a cube, coming out to 73 cal. So how do we deal with this? Because obviously there was a big concern that, our workers might be going out there underdonned, underdressed for the exposure. And there's a couple ways that you can deal with the reduction of arc flash incident energy. You can either obtain greater working distance. Okay. That's one way we can deal with the problem. Get farther away from the gear, the incident energy drops exponentially as it travels away from the gear. Okay. We could increase the clearing times. So instead of, 0.5 seconds, maybe, reduce to 0.3 seconds, that'll drop the incident energy. But the Z462 committee, their final determination was, well, it'd be better just to create a whole new category level 5, and hence the minimum requirement of 75 cal, which they chose to do. And that is what is now published in the 2021 revision of the Z462. Now, the 70E committee did not come to that same agreement. So here again, rather being aligned and of one common mind, the two teams decided to diverge from one another. The Canadians felt very strong about just creating a new level 5. The 70E felt that, no, we're going to hold to the 40. But in the 70E document, there are references, and particularly if you get the 70E handbook, the 70E handbook for electrical safety, there's a lot of commentary, additional commentary in there, where the 70 is basically now looking at, although arc-rated garments are available with ratings greater than 40 cal per square centimeter, and there always has been arc-rated suits greater than 40 cal. I think commercially available on the market today, right now, you can get suits all the way up to 140 cal. So we've always had arc flash suits that would handle greater than 40 cal. And the 70 basically says, now, although there are those garments that are available, in their informational notes, they are very quick to remind us that the extreme dangers of the concussive forces, the sound and the shrapnel that occur during the arc blast event, particularly when dealing with incident energies that exceed 40 cal, can be quite devastating. Again, they go on to further explain that arc-rated garments with higher ratings can be used by employees when they are testing for the absence of voltage or are performing some type of diagnostic task, and they are within the arc flash boundary of the equipment with a higher level of incident energy. The garment can, definitely protect them from incurable burns, but the garment is not intended to provide arc blast protection. So we kind of see the 70E is still kind of putting that alarm going. We don't really want to publish a level 5 because, okay, that's great. You're protected from the thermal burn. You're not going to get the life-threatening third-degree burns and everything if everything works well in your garment. But 70E really wants to remind us to consider that arc blast. The garment is not a bomb suit. The garment is not going to do anything to reduce the organ trauma that you may face, when hit with that pressure wave or those concussive forces, the flying shrapnel, etc. So again, I'm not a voting member on the 70E. I was not in these sessions, but just looking into the documents and being a student of life myself and attending various webinars and so forth on the subject, I can start to put the pieces together of what the various mindsets were and where we see that divergence taking place. Now, another area that we do see a divergence between the two standards is in what we call the table method of determining PPE. Both documents recognize that there's two basic methods for determining what PPE I need to don. Either it can be done through an incident energy analysis or an arc flash study, where an engineering company comes out, does a formalized study. They use the proper calculations in the 1584. And the end result is we have very detail-oriented arc flash labels on the gear, specifically telling us what the exposure incident energy is, what the working distance is, et cetera, et cetera. So that's one way that I can effectively select what gear I need to don to be safe. Okay. Now, in the absence of an arc flash study, in the absence of having these labels, the other method is the 70E and the Z462 provide reference tables where you identify the type of gear you're going to be working on. You identify the maximum available fault current that can be delivered to that gear. What is the clearing time of that gear? So you do have to do calculations here. But if you find a match in the table, it will tell you what level PPE you need to don and at what distance you need to establish for your arc flash boundaries. Now, here, the tables I'm referring to, if you're a 70E user, these would be tables 130.7, C, 15, A, and C would be the ones specific that I want to draw your attention to. If you're a Canadian reader of the 462, this would be tables 6A and 6C, okay, in their literature. Now, these tables, they are really good, but somewhat intended toward more of an advanced technician. You've got to know how to calculate fault current, okay? Believe me, not everybody knows how to calculate fault current, okay? You need to ascertain what the clearing times are in order to effectively use these tables. So we actually see two areas where the Canadians took a slightly different path away from the 70E. One area is the table 6A and 6C now also include their level 5 category to it. If you go to the 70E tables, 130.7, C, 15A, or C, you will only see reference up to level 4 or category 4 clothing. Okay, so that's one area that we see a separation. But the Canadian team went even one step further, recognizing that these tables really are more for an advanced learner, someone who has those skills to make those calculations and so forth. They also created a new annex and a new table called Table V.1, where it is a little bit more intuitive. I mean, it's conservative in nature, like these tables are, but you would not have to do these calculations of fault current and everything if you were using Table V.1. So this is not yet another area where we see a little bit of this separation taking place. And particularly like when I do qualified electrical worker training, I'm always very keen to make sure that I understand my audience. Your electrical safety program, is it based on the 70E? Well, then obviously I want to make sure that, I'm drawing the information and everything from the 70E and what has changed from one edition level to the next. But if I have, Canadian workers in the class, obviously I want to make sure that I'm doing them justice. Particularly, it used to be easy. The two documents were in alignment. But now I have to address the differences between documents, as well in my class, particularly if I have, Canadian as well as, US. And I mean, there's other countries that follow the 70, not just the US, but now I really need to decide, or ascertain in my class, are there Z462 followers as well as 70E followers, and make sure that I now not only address changes in addition in revision levels, but now address changes within addition levels. So that kind of wraps up and concludes the key elements that I really wanted to bring forth in this broadcast, Matt.
Well, and before we go, put our cryon down there. Hey, surprise, we have our own training. So I think just big picture, it doesn't matter whether you're going to go with Protec or you're going to go with somebody else that's doing the training out there. You need to make sure you do the 2021 update. Like look for, like if you just do a search online, a lot of people still have the 2018 update and they haven't done the 2021 update. So make sure that you verify that you're getting these 2021 changes in your class. Before we go, let's talk about our class a little bit. So we do have one coming up in July. It's the 3rd. What's the dates on this? July 18th through the 20th. So we do a 2.5-day course. Mm-hmm. So you want to explain like the setup and how they do? We do a hybrid, really. It's online, but it's instructor led. It's live with you, and there's a test at the end. So just kind of walk through what the curriculum is for that.
In our course, obviously, right at the very beginning, I kind of refer to Module 1 as understanding the why behind electrical safety training. And all of the standards and all the legislation kind of insists that this is incorporated into the training. Why is this training important? Well, one is an understanding of the legislation. One is an understanding of the electrical safety program that your company built. So again, if they were following the 70E, what were the elements that went into it? What were the policies, the procedures, the content, et cetera, et cetera. So we cover in Module 1 the why to the training. From there, we go into the second module, which we kind of call hazards associated with electricity. And we do a deep dive breakdown into electrical shock. What is it? How dangerous? What is the impact on the human body? So we start talking about current levels that the human body can, sustain without injury or with injury. Time duration of that current in the body, so we now have an understanding of where some of these protective clearing times, have come about and are being used. So we do a deep dive into first electrical shock and understanding it, and what are you protecting yourself from in electric shock. So again, when I look at my PPE, my arc flash suit does not protect me from an electrical shock. My rubber gloves protect me from an electrical shock. So when am I going to be exposed to the possibility of a shock? When do I need to don my gloves, versus just my arc flash suit, et cetera, et cetera. We take a deep dive into arc flash. What is it? It's protection from thermal burns, okay? Preventing my body from getting third-degree life-threatening burns, okay? We talk about the limitations of PPE and so forth in here. And then we go in and we talk about the third hazard, the arc blast, and what it is all about. We also start talking in a practical sense of like when you do your risk assessments, take into consideration body placement in front of the gear and so forth. Because again, if let's say I want to further protect myself from blast, if I'm standing directly in front of the gear, I'm hit with it, okay, I'm taking the full impact of the blast. Now, if there's a wall behind me, I may be thrown into that wall and I may sustain severe bone breakage or organ trauma. Can I perform the task by standing to the side? Again, I hit with the blast, but my body's not taking the full force. It may push and throw me down the corridor. I might get bumped and bruised and beat up a little bit on the way, but my body is allowed to move with the energy. I would have a better chance of surviving it. So we try to always teach this practical, here's the knowledge, but how do we apply it to our risk assessments? How do I apply it to the manner of how I'm about to perform this task? From there, we go into risk assessment and identifying hazards. And particularly when we get into identifying hazards, we really start to take the learner or the student into electrical theory as well, because there are invisible dangers. And if you have never had electrical theory training, truly understanding what is meant by capacitive coupling, induced, electrostatic fields, electromagnetic fields, these are just terms if you've never really had formalized training. And the fact that they're invisible, a lot of times are overlooked and they are not recognized as being a hazard. So in the third module of recognizing hazards and performing risk assessments, we really drive home these type of concepts to the learner. Because again, the old adage, if I can't recognize it as being a hazard, ignorance is bliss. No, ignorance can be life-threatening if you've never recognized the hazard. So we really try to enhance the learner's knowledge and expand their minds of what to be looking for when putting together their risk assessments. As we move on in here, again, we really start talking about PPE, performance levels. How did the PPE get the performance level? How to care for the PPE to maintain a performance level, et cetera, et cetera. We talk about creating an electrically safe work condition or lockout, tagout policies, practices, and procedures. We go into a deep area there. And then we also talk extensively about grounding, protective grounding, both the use of station grounds and the use of personal grounds. How do we establish equipotential zones? How do we size a ground appropriate for the potential maximum available fault current and clearing time if that line were to become accidentally energized? Throughout the training course, again, a lot of this is all transfer of knowledge, right? So how do I go ahead and assess that the learner is taking this in? So we do have lab projects where I can now assess their knowledge and how they received it. But also in these lab projects, I can also measure their ability to use the information in a practical manner. Okay. So in our training class, it is an instructor-led online class, just so that we can offer it, to a wide geographic area, reduce travel costs and everything to companies in order to get their workers in this course. But we do add the interactive elements, the assessments, and in the labs, to the best of our ability, we also start to work in the measurable of the training, applied knowledge. How did they apply what they learned? So that's kind of a 30,000 foot view of our training class and what we are setting out to accomplish.
Right. So in just 2.5 days, so they're doing all the theory and the practicum on the first 2 days. The lab is on the last day, I guess. Is that correct? You do the lab on the last half day, and then they take the test.
Yeah, actually, the first day is just a lot of transfer of knowledge. Although we do try to make it interactive, obviously, there's a lot of exchange and conversation that goes on in that day. But in day 2 is actually where you're going to be working on the bulk of your labs. And then in day 3, we kind of do a overview of everything, some conversations, and then launch you into your final exam where we can assess what you actually learned in the class.
Great. And then, I mean, benefits of doing it the way we do it. Obviously, you're not doing the 1 hour rubber stamp just to get my piece of paper certificate, $49 class. Yet you don't have to spend the additional money to fly somebody in, put them up in a hotel. They have their restaurant per diems. They're not, they're out of the office, right? So here they can do it from their office. They can do it from their home office. They're just logging on to our classroom, and you're live with them. And so they don't have the expense related to that live in-person training as well. So, we're the happy medium, I guess we like to say. So if you're interested in our class, for our July class coming up, which starts the 3rd Monday of July, you can email us directly at training@protecequip.com. That'll reach both me and Tom. Training@protecequip.com. You see it scrolling across the screen there. If you want to see more generally about our training, you can go to protecequip.com/training to get a more overview of what we can do with learning. So, Tom, I really enjoyed this today. I think, we're coming into the summer. We're coming off of our first busy season of the year with outage. And I think a lot of people are going to want to start getting their training hours, getting their CTDs. Quick, one more plug too. If you like to get your NETA CTDs, we do our monthly webinar series. That's the 3rd Thursday of every month. So we have one coming up in July. You can go to protecequip.com/webinars to register for that and get in on the webinar. And if you watch it live, you're going to get a certificate that you can redeem for 2 NETA CTDs. So that doesn't happen on the replay. But if you do watch it live, you get your 2 CTDs. So lots of good stuff happening in July. And what do you think? What do you guys want to talk about next? Email Tom and I, let us know. I think we're going to have some manufacturers as live guests coming up in shows. And we're moving. We're moving in August, right down the street in Dallas, our headquarters. So we'll have a studio. So we'll be able to bring in guests. And we're not Joe Rogan or anything, but we're going to do more studio style stuff. I think we're going to have probably the Mega guys in, AEMC, some of our other manufacturers, maybe some knowledge experts from IEEE and from NETA coming in the fall. So stay tuned. And we really enjoyed hoping we we're able to give you some education today, and we'll see you on our next live event.
Thank you, everybody, for attending. Always appreciate, having our friends out there in the audience.